So we're going to give you an overview of the sagebrush biome, and per Tom's instructions, we're hoping it's sagebrush 201, not 101. Let's go on to the next slide. When it comes to studying sagebrush, I think I knew I was in pretty deep when I was out in the field with Al Winward and Durant MacArthur. And Al would look around and say, this looks tetraploid. And another stop, Durant would sniff the sagebrush and say, this smells diploid. And I've never got to the level of those two have it keying into things. Another thing to point out on this slide is that the root system can go 2.5 meters deep, at least on basin big sage. And we can move on to the next slide. What the biome consists of, different ecologists have had different opinions. Chance and Zahn in 1924 mapped this area in central Wyoming as sagebrush. All the other ecologists of that era considered it to be grassland. In the report, The Western Range in 1936, McArdle et al. Indicated that sagebrush had increased or encroached in this area due to grazing management since the turn of the century. And then we have the Palouse grassland and the shortgrass prairie up there that we know have some sagebrush, but how much makes sagebrush biome is up for debate. Next slide, please. We do know that we have sage grouse in those areas, or that we did. And we do know that when grazing reduces the competition from grasses, that sagebrush has an opportunity to increase in those areas. So as we think about the sagebrush biome, we need just to remember that it's not a trivial task to define what we're talking about. Next slide. This is my compilation of 30+ years experience in this arena. We've got 22 taxa oriented against a climatic gradient from warm, dry to cold, wet, and a soil moisture gradient that looks like it's a little chopped off at the bottom, but low water capacity soils on the left and high water capacity on the right, or even seasonally flooded. So these gradients are pretty complex in themselves. The climate elevation gradient includes annual precip, the timing and form of precip, the growing season length, drought cycles, temperature extremes, and drifting snow. The soil moisture gradients influenced by soil depth and texture, the rock content, soil chemistry, saturation or flooding periods, runoff and infiltration rates, and topography, and whether the site receives extra moisture through run-on from adjacent areas. And many combinations of all those factors can give you the same plant community or the same sagebrush. Next slide. And the grasses and forbs differ from each other and from sagebrushes in their response to these gradients. And in many cases, they have wider amplitudes in any one sagebrush. So in this one, I guess the widespread ones are Idaho fescue and blue bunch wheatgrass, which occur with all these big sagebrushes and also occur with many of the dwarf sagebrushes. But this diversity is really the basis for resilience. Species differ in their contribution to ecosystem function, and they also differ in their responses to disturbance. And in a pristine system, if we have such a thing anymore, you have several species that contribute to each function, and those species all respond somewhat differently to disturbance, so that regardless of what impact there is, there's still some species helping provide that same function. And when we start losing species, we start losing resilience. Next slide. And from the 1850s through the 1930s, the plant communities of the biome were drastically altered by livestock grazing, and in large part because of repeated early spring grazing. The 1936 assessment called the Western Range basically said, you know, we've walloped just about every acre out there. Range depletion is nearly universal under all conditions and ownership. Plant cover in every type is depleted to an alarming degree. Weeds from foreign countries are invading every type. So the situation going into the Dust Bowl was pretty bad. Next slide. So they say that from their estimation, in the sagebrush steppe, which is where you have more grasses and forbs, the grazing capacity was reduced by 60 to 90% compared to pre-settlement conditions. The upper right photo is a picture of sagebrush steppe up in Montana. And the lower picture is the sagebrush shrubland, Wyoming big sage western wheatgrass in southern Wyoming. So the loss of the herbaceous cover was followed by increases in sagebrush cover because shrub seedlings were released from the herbaceous competition, and the loss of fuels made fires less frequent. And those changes were also accompanied by soil loss and compaction that limited the reestablishment of the native grasses and forbs. These are all conclusions of that 1936 report. Next slide. And competing plants limit each other's abundance. They don't determine each other's abundance. So here we have a boundary regression depicting the competition between sagebrush cover and herbaceous cover. These are from mountain big sagebrush communities in western Wyoming that I worked in for several years. So these are some the regression line would be similar to the line in the old Lotka-Volterra equations for two species competing for a single resource. So real world's not that simple, so there are lots of points below that line because of various disturbances and management impacts. Go on to the next slide. Here, this same set of points are color-coded by seral stage, or you could say departure from site potential. The late seral, or the healthiest stands, tend to be near that line. The early seral ones tend to be farther from that line, but there are exceptions in all these cases. And the seral status in this case, or the departure, is not based on the amount of sagebrush cover. It's based on the composition of the herbaceous community. You look at the figures in the lower left, late, mid, and early all have about the same sagebrush cover. There is a decline in bitterbrush cover, a decline in blue bunch, decline in early balsam root, and then total shrub covers a little bit of a decline possibly, and grasses there's a big decline, bare soil a big increase. Next slide. Talking about post-fire recovery of sagebrush, there's basically been two kinds of studies. One is a long-term study where they keep studying the same piece of ground for decades, hopefully. And then there's chronosequence studies where they go visit different sites where they know what year they burned and how long it's been since they've had to recover. And long-term studies generally have a lag period and then pretty much linear growth in sagebrush cover. And if they go long enough, then they have some decline later on, if you look at the green and the dark blue or purple line there. And I think that in interpreting the chronosequence studies, we need to think about that particular pattern. in interpreting what those chronosequence studies mean, because they're each just an individual point in time with no context. And these long-term studies are the closest thing we have to giving us a context. So, and this graph is percentage of the unburned control sagebrush cover. And it looks like the lag in recovery can be, you can get immediate recovery, or it can take up to 25 years to start getting that linear growth phase, and return to pre-burn cover taking 25 to 50 years. Next slide, please. But how we should define recovery is an important question as well. The control covers in those studies range from 4 to 71% in mountain big sagebrush. Neither one of those really sounds like recovery to me. And our management goals are usually expressed in some absolute amount of cover. The sage-grouse guidelines give you specific cover ranges for different types of habitat. So all of the chronosequence data and long-term studies say that you can get 20% cover of mountain big sagebrush after a fire in as few as 10 years or as long as 50. So I think it might make more sense to talk about the absolute cover of sagebrush we want out there for a given purpose than to talk about percent of the control. Next slide. And the other issue with fire and sagebrush has been talking about the fire return interval. There are 3 different ways of describing those, and there are 3 methods that tell you very different things. We should not assume that one is right and the others are wrong. And we also need to think about each of these 3 measures and how they are relevant to the plant community dynamics. So the mean point fire interval is the average frequency for points within a study area. Typically it's fire-scarred trees that are used to do this, so there's much more data in mountain big sagebrush than other types. Then the composite fire interval is the frequency of firing occurring anywhere within the study area. And then the natural fire rotation is the time in which the cumulative fire sizes equal the acreage of the fires of the study area. So the composite fire interval gives you the shortest estimates. And in sites that are mountain big sagebrush site potential, 12 to 25 years. The point intervals give you estimates of 25 to 100 years. And then the natural fire rotation gives you 70 to 300 years. And natural fire rotation has a lot more assumptions required to estimate the past fire sizes in order to figure out how long it takes for those sizes to equal the study area. And it's also probably more subject to the size of the study area and whether you've included areas that typically wouldn't burn. Next slide. And then the site potential determines how the fire interval affects the landscape mosaic. So long fire intervals allow the potential veg to dominate the landscape, and short intervals interrupt succession and prevent the landscape from being dominated by the potential. So if we look at potential forest or woodland, an interval greater than 50 years, forest or woodland are going to dominate. If the interval is 30 to 50 years, then mountain big sagebrush can dominate. It's got that window, needs to recover post-fire. If it's 10 to 25 years, it's probably going to be grassland dominated. And for a mountain big sagebrush site potential, 30 to 80 years will maintain the landscape being mostly big sagebrush communities, and a 10 to 25 year will make most of the area grassland dominated. So we need to think about that landscape setting and what we expect to happen with a given fire return interval. Next slide. Okay, that's it. I warned you. It's easy to get in over your head here. So that concludes what I have to say. So any questions are welcome now.
Thank you, Dave. Appreciate that. So just checking quickly here, I don't see any hands raised, and I don't believe we have any questions that were submitted at the moment. We certainly had some questions about people trying to manage their sound on their end to be sure they can be heard. Are there any questions from any of the attendees? All right, seeing none, thank you so much for that presentation, Dave. Really appreciate that overview. It's super helpful for us.
Yes.
So we're going to go ahead now and turn this over to Drew Bennett. Drew is with the University of Wyoming, and he is going to be presenting on human dependencies on sagebrush. Drew?